I'm on the Farnell website. Farnell here in the UK, big supplier of electronic components, looking at analog to digital converters, and again they've got a filter where you can filter on various criteria. So we're looking specifically for I2S. Here we are, and they've only got 8 products, so we might as well just look at those. So these two no longer manufactured, we can discount those. That looks like a QFN package. Not impossible for me to solder, but I'm not terribly keen on QFN. And then they've got these two. In fact, they're both the same, but they've just got different pricing for different quantities. So in small quantities, £1.84 dropping to £1.42 for 10 off, and £1.17 for 100. Nearly 2,500 in stock, so no particular problem. So 24 bits, yeah, 96 kilohertz, 4.5 volts to 5.5 volts supply voltage, so same supply voltage as the Raspberry Pi Pico, so that's good. So I think these are going to be worth a look. So I'll download the data sheet and have a look. This is the data sheet for the PCM 1808 by Texas Instruments, and look at this, under applications, electric musical instrument. That sounds right up our street. So good signal to noise ratio, flexible PCM audio interface, can be master or slave, 24-bit built-in anti-aliasing filter. What else have we got? It's a 14-pin T-SOP. That's good because they're reasonably easy to solder, so I like that. What else have we got? All sorts of nice timing stuff, which we'll probably have to get into later. Application information, suitable for a wide variety of cost-sensitive consumer applications. 5-volt analog and 3.3-volt digital. So that's it just gets better and better, because the GPIO pins from a Raspberry Pi Pico are 3.3 volt, and of course the Pi Pico itself takes a 5-volt power input. So that's perfect. And they've even got a typical application with that looks like anti-aliasing filters on the way in, and a load of decoupling caps and some control logic. What else we got? Oh, they've even included a specimen PCB layout. It all looks a bit obvious, but brilliant. Including all the wires through to couple the ground planes. That's very nice. So yeah, I think I'm going to get some of these. Back on the Farnell website, seeing as I'm going down the I2S rabbit hole, I may as well look for the other side of the equation, the DAC. So digital to analog converters. Again, let's have a look at the interface. Find I2S there. Oh, only 4. Okay, 2 in stock. Don't think I'll be buying them. 2 in stock, so that's the same thing. And they've got the PCM 5102. So supply voltage 3 volts. T-SOP again. That's good. And I2S. So I think this is worth a look. So I'll have a look at its data sheet. This is the data sheet for the PCM 5100 series. So it's a 32-bit audio stereo DAC, typical performance with a 3.3 volt power supply. So there's that 3.3 volts again. So that's good. Small 20-pin T-SOP package. That sounds good. typical application is actually giving line output levels, so plug it straight into a pair of headphones. It's the pinouts. What else we got? All the usual performance characteristics. Timing, we will doubtless need to get into that later. Okay, that looks like soft muting circuit. And a couple of typical application circuits. These look identical, apart from there the SCK signal is tied to ground, so PLL, so that's presumably it's running its own phase lock loop inside, so it will latch onto an external clock of some sort, and presumably there it's being driven by an external clock. But looks very straightforward. A few capacitors. They've separated the power supply for some reason, possibly a clean 3.3 volts for the audio. AVDD sounds like an audio output reference and an audio ground. But yeah, I think this is worth a look, so I'm going to get some of these as well. A couple of days later, here they are from Farnell. This is the PCM 5100, and these are the PCM 1808. So they're pretty small. They're TSOPs, but I've got these carrier boards, and I can solder them onto that, and that will make them a lot easier to work with. And they're, the pins were kind of breadboard spacing, so I won't bore you with the details, but I'll be back shortly. And here they are, so soldered onto their respective carrier boards, so I can get my breadboard out and have a play.